Welcome to the DIY Honda Garage channel. In this presentation, we will discuss Diagnostic Trouble Code P0365, which indicates a CMP sensor circuit no signal issue on the Honda Pilot models from 2016 to 2022. This DTC is crucial as it highlights a problem related to the Camshaft Position CMP sensor that can significantly affect engine performance. Understanding this code is essential for effective troubleshooting. The CMP sensor plays a vital role in determining the position of the camshaft, which is necessary for proper fuel injection timing and ignition. If this sensor isn't sending signals to the powertrain control module, PCM, the engine's performance can suffer, leading to potentially serious issues. Throughout this troubleshooting guide, we will analyze detailed steps to identify and rectify the problem. The Diagnostic Trouble Code P0365 occurs when the camshaft position CMP sensor fails to send a signal to the powertrain control module PCM. The CMP sensor is responsible for relaying the camshaft's position, which is critical for appropriate timing of fuel injection and ignition. When positioned on the engine, it can typically be found near the camshaft assembly, connected via a 3P connector. The PCM receives the sensor data and adjusts engine functions accordingly. If the sensor malfunctions, it may lead to erratic engine performance or a no-start condition. This error can indicate a potential wiring issue or sensor failure, requiring a systematic approach to identify the root cause. Various factors can lead to the activation of DTC P0365. An open circuit in the wiring connected to the CMP sensor may prevent the signal from reaching the PCM. This means that there may be a break in the wire, leading to a disruption in communication. A faulty CMP sensor itself could inherently lack the ability to generate and send accurate data due to internal faults. Furthermore, poor connections or corrosion at the PCM can lead to unreliable signal transmission. Lastly, intermittent signal failure may occur under specific conditions, such as high temperatures or vibrations, making it challenging to reproduce the issue. Each of these causes must be examined during diagnostics to ensure comprehensive troubleshooting. When DTC P0365 is present, several symptoms may manifest in the vehicle. First, the engine may experience performance issues, such as misfires, decreased power, or hesitation during acceleration. In some instances, drivers may encounter a no-start condition as the PCM cannot properly time fuel injection or ignition without reception from the CMP sensor. Typically, the check engine light illuminates on the dashboard, signaling the need for diagnostics. Additionally, irregular idle behavior might be evident as the engine struggles to maintain stable RPMs due to inconsistent data from the CMP sensor. Recognizing these symptoms can aid in identifying problems early in the diagnostic process. The first step in troubleshooting DTC P0365 involves verifying the problem. Begin by turning the vehicle to the on mode without starting the engine. This helps power the vehicle's electronics without engaging the engine. Next, clear the DTC using the Honda Diagnostic System, HDS, which resets memory codes within the vehicle's computer system. Once cleared, start the engine and monitor the diagnostic tool for any pending or confirmed DTCs. It is crucial to check if DTC P0365 appears again. If it does, the failure has duplicated, confirming that further investigation is required. Conversely, if the DTC does not reappear, this may indicate an intermittent error, necessitating additional checks for poor connections or loose terminals. Step 2 focuses on checking the open wire condition of the ignition power IGP line. Begin by turning the vehicle off completely to prevent any electrical shorts during the diagnostic process. Next, disconnect the CMP sensor by removing the 3P connector, which allows for direct testing. After disconnecting, switch the vehicle to the on mode, enabling the electrical systems without starting the engine. The next step is to measure the voltage between the designated test points on the CMP connector and body ground. Specifically, test point 1 corresponds to the CMP sensor connector number 1, while test point 2 is a reliable body ground. If battery voltage is present, this indicates that the IGP wire is functioning correctly, and testing should continue to the next step. However, if voltage is absent, it necessitates repairs to the open circuit in the IGP wire, leading to the relay circuit board to restore proper function. In troubleshooting step 3, you want to determine the possible failure area related to the TDC line. With the vehicle still in the on mode and the CMP sensor 3P connector disconnected, measure the voltage between the specified test points. Test point 1 refers to the CMP sensor connector number 3, while test point 2 is again a body ground. The objective here is to check if you are receiving a voltage of about 5.0 V, which is expected under normal conditions for the sensor's operation. If the expected voltage is present, it suggests that related wiring and connections might be operating properly, allowing you to progress to the next step. However, if there is no reading close to this expected voltage, it may be indicative of broader issues that warrant further investigation. Step 4 involves conducting an open wire check on the LG/TDC LG line. Maintain the vehicle in the on mode with the CMP sensor 3P connector still disconnected to facilitate testing. Use the designated test points, with test point 1 as CMP sensor connector number 1 and test point 2 as CMP sensor connector number 2. Measure the voltage to confirm the presence of battery voltage between these points. If battery voltage is detected, you can confidently state that this specific wire is functioning correctly, indicating that the CMP sensor may be defective and thus requires replacement. Conversely, if the testing reveals no battery voltage, then the issue may rest within the wire itself, indicating that repairs must be made to address an open circuit between the CMP sensor and the engine ground point G100. In troubleshooting step 5, the focus shifts to identifying any shorted wires along the TDC line. First, turn the vehicle off to ensure safety during the procedure. Using the Honda Diagnostic System, HDS, jump the SCS line, which allows for diagnosing systems while ensuring there is no power to the circuit. After a waiting period of more than 1 minute, disconnect the PCM, Powertrain Control Module Connector B51P, to isolate the circuit. At this point, it is vital to check for continuity between the test points using a multimeter. Test point 1 corresponds to PCM connector B51P, number 51, and test point 2 is a body ground. If continuity exists, it suggests a short in the TDC wire exists between the PCM and the CMP sensor, necessitating immediate repair. If no continuity is detected, you should proceed to step 6 to further investigate potential issues. The final step in this troubleshooting protocol involves checking continuity on the TDC line to ensure it's functioning correctly. With the vehicle turned off, ensure the CMP sensor 3P connector is still disconnected to isolate the components effectively. Again, employ a multimeter to check for continuity between test points. Test point 1 corresponds to the CMP sensor 3P connector number 3, and test point 2 corresponds to the same numbered pin on PCM connector B51P. If continuity is confirmed, it indicates that the TDC wire is in good condition, and the next course of action should involve looking for any authorized service information related to the symptoms or DTCs being investigated. However, if continuity is found lacking, This suggests an open wire between the PCM and the CMP sensor, which requires immediate repairing to restore proper functionality. After conducting all necessary repairs related to DTC P0365, it is essential to verify that the repairs were effective. Begin this process by clearing the DTC codes from the vehicle system using the Honda Diagnostic System, HDS. Following this, perform a test drive on the vehicle to simulate normal driving conditions and ensure that everything functions correctly. During the test, remain vigilant for any reappearance of the DTC, which would suggest that the issue might not be fully resolved. Additionally, pay attention to how the engine performs, checking for any symptoms that may indicate lingering problems. It's essential to confirm that no issues are present following repairs, ensuring peace of mind for both the technician and the driver. Preventive maintenance plays a crucial role in combating issues like DTC P0365 in the future. Regularly inspecting wiring and connectors can prevent problems that may arise from wear or corrosion. Ensure that all connectors related to the CMP sensor and PCM are clean and securely attached to prevent loose connections that trigger faults. Additionally, checking for proper grounding points will further enhance signal integrity, ensuring that the electrical system operates efficiently and reduces the likelihood of faults. Scheduling regular diagnostics can catch potential issues before they become serious problems, promoting vehicle longevity and performance. Being proactive helps sustain the health of critical engine management systems. In conclusion, addressing DTC P0365, which indicates a CMP sensor circuit no signal, is essential for optimal engine operation. Following a systematic troubleshooting process helps pinpoint the root cause of the issue effectively. Each step outlined in this guide is crucial for diagnosing problems accurately, which can prevent undue stress on the engine and other components. Once repairs are completed, thorough verification ensures that persistent issues do not remain, leading to a more seamless driving experience. Finally, implementing regular preventive maintenance practices is vital to avoid similar errors in the future, ensuring that the Honda Pilot performs well over the years. Keeping in mind the importance of the CMP sensor reinforces the necessity of consistent attention to automotive diagnostics. Please like and subscribe to the channel. See you next time!